These here are two major responsibilities that you would see in many analytics engineering job description. And if you're new to the term analytics engineering and still not familiar with what analytics engineer does, I'm here to spread light on what these two roles involves, and particularly with the use case of DBT, data build tool. The first is to design, build, and maintain data models using DBT, which is the center of what analytics engineers supposed to be doing at any company. While the second is to develop and optimize data pipelines and transformation within some sort of data warehouse. Now, these are purely for reporting and analytics, right? Which is completely different from that of a data engineer. And it's another reason people tend to mix the responsibilities between a data engineer and an analytics engineer because it sounds a bit familiar. So in this video, I'll be sharing more light on these two particular roles. Now, for the first one, which involves designing, build, and maintain data models, the first thing you should know is what are data models, right? So if you're not familiar with what data models are, here's a description. So a data model is a clean, organized, and useful representation of a business logic, right, turned into data tables. And that's the entire idea of it. What is a business logic in this context is something the business uses to make meaningful decision of. And really, a business logic could be revenue across probably different regions, or it could also be a model that supports like some key analysis, right? It could be a model that supports, revenue, profitability analysis in a company, or growth analysis in a company, under marketing, funnel analysis, right? That could be the end that could be the end product of the entire role of an analytics engineer to prepare these meaningful models for data models for end users to make use of. And the end users are usually people like the data analysts within the company or the BI developers. And you would see here, this is an example of useful models, right? These are usually done in a data warehouse like BigQuery, right? And all these are tables within BigQuery. So an end user can go in and pick any particular table that they need, and you can see it's already highlighted. The major thing that to note is every model created by an analytics engineer, the end result should be something meaningful and useful to the data analyst or any of the stakeholders. You can see here that the data models here, which are tables, represent something within that company. Now, this represents orders. This represents funnel analysis. This represents attributed orders. And so, one thing to note is that creating data models is very heavily tied with understanding the business logic and operation. If you don't understand the business side of things, you can't really create models out of nothing, right? So, which is a very important distinction, and is one of the biggest distinctions between a data engineer and an analytics engineer. A data engineer is largely focused on the technical infrastructure of everything, while we tend to focus on the technical and business side of things. So these here are useful models, and DBT is the key tool in building models. And really, what are models in DBT? Models in DBT are still just SQL statements, right? They're still just SQL scripts, and nothing technical than that. I mean, it gets technical, but they are still SQL scripts, right? And SQL scripts is what represents a model in DBT, is what's used in creating a model in DBT. Now, the second is data transformation. So here, the second role here is develop and optimize data pipelines and transformations in modern data warehouse environments, right? So you're going to be creating data transformation, you're going to be transforming data and also creating a data pipeline, right? So what's the idea of data transformation really? To me, it really just involves any process, right? Any process involved in changing a data from one structure to another, from one form to another, from one shape to another, is referred to as data transformation. But the ideal definition of data transformation, because we are not just transforming data for the sake of transforming, the ideal definition of data transformation is the process of converting raw data structured into structured and useful formats, right, for the end users. This mostly involves cleaning, deduplication, typecasting, and joining. And you could see here that in your data warehouse, you would have some raw sources. Now, if you were to go into any of these sources, you would see is mostly messy or in an unstructured format that is going to be very difficult for end users to make use of. They could make use of it, but they are going to be it's going to involve a lot of heavy SQL scripting. And the idea here is you just want them to have the clean data instead of spending time manipulating and cleaning those data themselves, right? So you perform transformation at various stages, right? You could transform your raw data into useful tables and transform those useful tables into business logic, right? Any step taken in turning data from one shape to another is referred to as data transformation. And again, DBT is the key tool in performing this transformation, which is still just SQL under the hood. And at this point, you might be wondering, if we are going to be using SQL within DBT, why not just use SQL? So I'll get to that later on in the video. So you can see from messy sources to readable tables and to useful models. That is the process of this transformation. Then last is the data pipeline. Now, the data pipeline is really just the steps involved in moving your data from one source to a destination. That is it, right? The data pipeline is a series of steps of transformation that moves data from a source to a destination. It may not even involve the transformation, but it's mostly always involve transformation. It involves from picking up the data from the source, right? There's no transformation there, but it's still a pipeline. It's taking data into your storage, and a large part of the transformation is done within your storage, and then it's taking that data down to a destination. Your destination could be Excel sheets, BI tool, right? Whatever the destination may be. Another intuitive example of this process of a pipeline could be someone that works in a company, and that company generates like hundreds of orders daily, on a daily basis, or thousands of orders on a daily basis. And each day, the marketers would want to come in and they want to see what's happened the previous day, right? So what's happened with the orders the previous day. They want to analyze the orders and figure out what's happened. So in that case, the whole transformation process is usually carried out from wherever the data is being generated from wherever the source of data is. It may be Shopify, it may be a completely different tool or CRM, right? And then it's taken into a storage like their database. It may not necessarily be a data warehouse. It could be taken into MySQL or some sort, and then it could be exported into on a daily basis, right? You could perform some transformation on the data inside the storage, and that data will now be exported on a daily basis as an Excel sheet to a web portal, right? Or a OneDrive, or to Microsoft SharePoint that the entire organization uses. So that could be a destination also. It's not always necessary it's a BI tool, right? So that's the idea of a data pipeline. In this case, really just the journey of the data. And the reason why these three concepts are pretty important for an analytics engineer is knowing the business context lets you create good data models, right? To create those data models, you have to know how to properly transform your data from the raw format it is to something useful. And your pipeline is really just, you have to know the technical parts of building a pipeline, because if you build a poor pipeline, everything breaks, right? You could create a very good model that returns what is needed, and then your data really misses something, right? You could have an issue with slow changing dimensions if that is not accounted for, or late incoming data, right? So knowing how to build a data pipeline is still very fundamental and technical to an analytics engineer. And the clear line between an analytics engineer and a data analyst is Data analysts don't build pipelines, right? They derive insights from data. But data engineers, they are way more technical than analytics engineer, right? They may not necessarily be involved in building data models. And then lastly is the advent of DBT. The question has always been, why use DBT if you could just use regular SQL? If you're used to regular SQL, then I think the differences will be clear, right? If you've been using regular SQL before now and you've tested DBT, the differences will be very clear, like day and night. But if you're unfamiliar with SQL, it's going to be harder to explain why DBT. But then you wouldn't even need to make that difference or make that distinction. So number one, SQL is difficult to automate, right? The entire process, if a particular script, so you could write like multiple scripts in SQL, and a particular script, your script one could depend on script two, but then script two will have to run before script one, right? You have to find a way to make sure these scripts run at in the proper order, in particular order they're supposed to run. And this is what comes out of the box with DBT. Also, DBT is way more modular than SQL. So SQL is just a bunch of hanging scripts around the place. So DBT, it's packaged together and has one script easily references the other scripts, and we know how to tie all our SQL scripts together. You can see a hierarchy when you're building out your DBT project. In SQL, it's hard to locate the source, right? Except you organize your project, your SQL scripts properly. But in the cases of writing SQL scripts in a data warehouse, it's still very hard to organize those scripts properly. But with DBT, you can see a clear lineage of how your data flows from the source to the end, or to wherever, to all the models are using that particular flow of data. You would be able to see everything clearly. And then lastly, automated testing is extremely difficult in SQL, but in DBT it's inbuilt. You don't need to manipulate or perform any extra work. It's inbuilt in DBT. And these are not the only characteristics of DBT. There are more to it, but these are the few important distinctions between using DBT and regular SQL. And the reason is, at the end of the day, SQL is just a query language, right? All SQL does is tell the database to give me data, nothing more than that. And because it's just a simple query language, and nowadays we are trying to build complex systems and applications of SQL, which is why DBT was invented for this purpose. So, in summary, among the many roles that an analytics engineer is responsible, these are the two major roles: to build and maintain data models and to design the data pipelines and transformation. Also includes designing the data warehouse, because the data warehouse is an analytical storage. A database is a transactional storage, but that's would be a video for another day. So as always, if you like the video, please leave a like, subscribe, and put on the notification bell icon to be notified of when I release future videos.